Okay, so get ready for this, because today we're taking a deep dive into the history of the internet.
The internet.
Yeah, that thing we use for pretty much everything these days.
Right.
But we never really stopped to think about, how it actually came to be.
Yeah, it's fascinating.
You've sent over a whole stack of articles and research on this, and wow, I'm already seeing some seriously surprising stuff in here.
Oh, I bet.
Did you know that the way the internet sends data, it's, breaking it up into all those little packets, that was totally resisted at first.
It's true.
People thought it would never work.
The idea of packet switching, as it's called,
Packet switching.
was so radical, so outside the box, that established communications experts practically laughed it out of the room.
Really?
They were so used to the old way of doing things, circuit switching.
Circuit switching, yeah, that sounds kind of familiar.
Yeah.
But remind me what that is again.
So imagine a dedicated phone line connecting you directly to the person you're talking to.
Okay.
That's circuit switching. The connection is set up just for you two.
Gotcha.
And
Right.
nobody else can use it during your call.
Right.
Works great for voice calls,
Yeah.
but it's not very efficient for data.
Okay, that makes sense.
Yeah.
So packet switching must be totally different then.
Totally different. With packet switching, data is broken down into these little packets, each with its own address label.
Oh, okay.
And these packets can travel across the network independently,
Interesting.
taking different routes, and then they're reassembled at the destination.
So it's not like a dedicated line then. It's more like sending a bunch of postcards
Exactly.
that all find their way to the same mailbox.
That's a great analogy. And it's this flexibility that makes the internet so resilient.
Yeah.
If one path gets blocked, the packets can just take a different route.
That explains why my internet still works, even when my cat decides to, sit on the router cable.
Exactly.
But okay, so before all that, how did we even get to the point of sending data between computers in the first place? I mean, weren't there simpler forms of communication before the internet?
Oh, absolutely. Think about telegraphs. Sending messages over wires using Morse code?
Oh, right.
Or radio telegraphy, transmitting messages wirelessly using radio waves?
Yeah, yeah.
Even telex machines, which were basically typewriters connected to a network,
Wow.
allowing you to send text messages around the world.
Okay, so we had ways to send messages, but it sounds pretty limited compared to what we could do today.
It was.
What were the big leaps that got us closer to the internet as we know it?
Well, we can't talk about communication without mentioning the pioneers of information theory.
Okay.
People like Harry Nyquist, Ralph Hartley, and Claude Shannon. They laid the mathematical groundwork for understanding how information is transmitted.
Information theory.
Yes.
That sounds pretty dense.
It is pretty complex.
Was that all just theoretical stuff? Or did it actually have practical applications?
Their work was crucial in developing more efficient ways to transmit data, whether it's voice, text, or images. Without their contributions, the internet as we know it wouldn't be possible.
Really?
Yeah.
So we have the theory, and then what
Yeah.
were the first baby steps, towards an actual network?
The invention of computers was obviously a huge leap forward.
True.
Early computers were massive, expensive machines, mainly used for scientific calculations.
Right.
But with the development of modems,
Oh.
we could start sending data between computers over telephone lines.
Ah, so that's how computers started talking to each other.
Yes,
But was it still like that circuit switching thing where one computer was directly connected to another?
exactly.
Oh,
It was
yeah.
still point-to-point communication, which meant you could only connect to one computer at a time.
That doesn't sound very internet-y.
No, not really.
So what was the breakthrough that allowed multiple computers to connect and share information?
Well, a key innovation was the concept of time sharing.
Time sharing.
This allowed multiple users to interact with a single computer simultaneously.
Oh, interesting. So instead of one person hogging the whole computer,
Yeah,
multiple people could take turns using it.
precisely. It's like having a party line on a telephone where multiple households share the same line,
Okay.
but take turns talking.
That's pretty clever.
Yeah.
It's a way to make those expensive computers more accessible to more people, right?
Right.
So time sharing was like a stepping stone to the interconnected world we have today.
Absolutely. These early networks, each with its own quirks and innovations, would eventually pave the way for the internet as we know it.
Wow.
Yeah.
Okay, so we're starting to see some familiar internet-ish things popping up here. But if these early networks were all separate,
Yeah.
how did they eventually merge into this global network we have today?
Uh-huh.
What was the glue that held it all together?
Well, there were actually a few glues.
Okay.
Early networks like the NPL network in the UK were experimenting with high-speed links,
Interesting.
but each network was still isolated.
So it was like having a bunch of super fast race cars, but they could only drive around their own little tracks.
Exactly. The real challenge was figuring out how to connect these isolated networks and allow them to communicate seamlessly.
I see.
And that's where the famous ARPANET comes in.
Ah, ARPANET, the granddaddy of the internet.
That's right.
Tell me more about that.
Okay, so ARPANET was funded by the U.S. Department of Defense, and it was one of the first major packet switch networks.
So they were using packet switching to send data between these institutions.
Yes. And this was a game changer because it meant the network could withstand disruptions. If one part of the network went down, the data could simply be rerouted through another path.
That's that resilience we were talking about earlier.
Exactly.
But if ARPANET was so revolutionary, why didn't it just become the internet as we know it?
Good question.
Yeah.
Well, ARPANET was a crucial step, but it was still just one network among many. There were other networks popping up, like the Merit Network and Cyclades, each with its own protocols and ways of doing things.
So it was like a Tower of Babel situation where everyone was speaking a different language.
Exactly. To create a truly global network, we needed a way to unify these disparate networks, a common language for them all to speak.
And that's where TCP/IP comes in, right?
You got it.
The foundation of the internet.
Absolutely. The development of TCP/IP, thanks to visionaries like Vint Cerf, Bob Kahn, Louis Pouzin, and Hubert Zimmermann.
Wow, what a team.
It was a watershed moment.
Yeah.
These protocols provided the rules for how data should be packetized, addressed, and transmitted across different networks.
So TCP/IP was like the Rosetta Stone.
Exactly.
That allowed all these different networks to finally understand each other.
That's a perfect way to put it. This open architecture networking was revolutionary because it allowed networks to grow and evolve independently while still being able to communicate with each other.
So instead of one giant monolithic network controlled by a single entity, we ended up with a decentralized network of networks, all speaking the same language.
That's the beauty of the internet's design.
Wow.
It's a network built on collaboration and shared standards, not top-down control.
And that's probably why we still call it the internet today. Wait, didn't I read that the name itself came from a typo?
You're absolutely right. Internet was originally a shorthand for internetwork.
Internetwork.
Which simply meant a network of networks. The name stuck, and here we are today.
From a typo to a global phenomenon that's quite a legacy. So we have all these networks talking to each other, sharing information at lightning speed.
Right.
Things must have really started to take off around this point, right?
Well, the transition from ARPANET to NSFNet in the 1980s really opened the floodgates.
NSFNet.
Expanding access to universities and colleges all over the U.S.
Wow, so we're talking about a nationwide network now.
A nationwide network.
But was it still mainly researchers and academics using it at this point?
For the most part, yes. But things were about to change in a big way.
Ooh. All right, I'm on the edge of my seat. What was the next big leap? You know, the one that brought the internet closer to what we know and love today.
Well, remember how we talked about high-speed links earlier?
Yeah.
Things were about to get a whole lot faster with the arrival of fiber optic cables.
Fiber optics. Now we're talking.
We are.
Those are the cables that transmit data using light.
Exactly. And this technology, capable of transmitting data at the speed of light, would become essential for the internet's future growth.
So fiber optics was the key to unlocking the internet's true potential.
Absolutely.
Wow.
But what's really fascinating is that the development of fiber optic cables relied on lasers.
Okay.
And get this. Lasers wouldn't exist without Albert Einstein.
Wait, what? Einstein?
Einstein.
The guy with the crazy hair and the theory of relativity.
That's him.
What does E have to do with the internet?
It's true. His 1917 paper on stimulated emission laid the theoretical groundwork for lasers, which revolutionized optical communication and paved the way for the high-speed internet we know and love.
Hold on.
Yeah.
So the next time I'm like streaming a movie or scrolling through social media, I can thank Einstein for making it possible?
You can.
That's mind-blowing.
It's like a chain reaction of scientific discoveries, all leading up to this incredible technology we have today.
Yeah, it really highlights how innovation isn't always a straight line.
Right.
Sometimes seemingly unrelated discoveries in different fields can have a profound impact.
It's all connected.
This is already way more interesting than I thought it would be. So we have a nationwide network, fiber optics are making it super fast, and we can thank Einstein for our cat videos.
That's right.
What could possibly happen next?
Well, as you might imagine, even with all these advancements, the internet's journey was far from over.
Oh no.
There were still some growing pains to overcome, some crucial transitions that would shape its future.
Okay, you've definitely got my attention. Let's dive into those next.
Let's do it. So it seems like fiber optics had solved the internet's speed problem.
Yeah.
But, there are always growing pains with a new technology.
Yeah.
And one of the biggest came on a day that became infamous, Flag Day in 1983.
Flag Day.
Yeah.
Okay, now I'm intrigued. What happened on this, ominous sounding day?
So to ensure the internet's continued growth and stability, a major transition was needed. All internet hosts were required to switch over to the new TCP/IP protocol.
Hold on. Just to be clear.
Yeah.
We're talking about, every single computer connected to the internet
Every single one.
having to change its way of communicating all at once.
All at once. It was a massive undertaking,
Wow.
requiring a ton of coordination and effort from everyone involved.
Yeah, can you imagine trying to get everyone on board with something like that today?
That'd be chaos.
Yeah, it sounds like a logistical nightmare. But why was this transition so crucial?
Well, without everyone speaking the same language, that is, using the same protocol,
Right.
the internet wouldn't be able to function as a cohesive network.
Yeah.
It would be like trying to have a conversation with someone who speaks a completely different language.
So Flag Day was like a massive language lesson for the entire internet.
Exactly. And to make things even more challenging,
Wow.
if a host didn't switch over to the new protocol by Flag Day,
Yeah.
they risked being cut off from the network entirely.
Yikes. Talk about pressure.
Yeah.
So, did everything go smoothly on Flag Day?
Amazingly,
Yeah.
the transition was relatively smooth,
Okay.
thanks to the hard work and collaboration of countless individuals and organizations.
It's a testament to the spirit of cooperation that was so crucial to the internet's early development, for sure.
I think so.
That's pretty impressive. But even with everyone speaking the same language,
Right.
there must have been other challenges, as the internet continued to grow. How did companies know their products would actually work together on this new and rapidly evolving network?
That's a great question. And that's where a unique event called Interop comes into the picture.
Interop.
Imagine a giant trade show where companies could come together and test their products for compatibility.
So it was like a real-world testing ground for the internet.
Precisely. Companies would bring their routers, servers, software, you name it, anything that connected to the internet and try to make it work with products from other companies.
That's so cool.
It was a way to ensure interoperability.
Interoperability.
Meaning that different devices and systems could communicate with each other seamlessly.
It sounds kind of chaotic, but essential.
Oh, it was a bit of both.
Yeah.
But interop was crucial because it fostered trust among companies and encouraged further investment in the internet.
That makes sense.
If companies knew their products would work with others, they were more likely to develop new and innovative applications
Right.
for this emerging technology.
Okay, so by the late 1980s, we have a robust, interconnected network built on open standards, growing rapidly thanks to fiber optics, and with companies working together to ensure compatibility.
We're getting there.
We're getting there.
Yeah.
But the internet we know today is so much more than just a way for researchers and businesses to connect, right?
Of course.
When did it start to become something that, everyday people could use and enjoy?
Well, in the early 1990s, a revolutionary development occurred that would change everything. The birth of the World Wide Web.
The World Wide Web. Now we're talking.
That's it.
This is the internet I grew up with. Websites, hyperlinks, all that multimedia content.
Exactly.
But before the web, what were people actually doing on the internet?
Mostly text-based communication
Oh, okay.
and file sharing.
So sending emails,
Yes.
participating in online forums, downloading files, but without the visual, user-friendly interface of the web.
That's right.
So it's like a text-only version of the internet.
Pretty much.
That sounds kind of boring compared to what we have today.
It might seem that way now.
Yeah.
But at the time, it was incredibly exciting.
Really?
Remember, this was a time when even having a personal computer was still a pretty novel thing for most people.
Okay, fair enough.
Yeah.
So what was so special about the World Wide Web
Yeah.
that made it take off the way it did?
Well, the web introduced a whole new way of accessing and interacting with information online.
Okay.
Instead of just text, you could now have images, graphics,
Yeah.
even videos embedded in web pages.
I see.
Plus, hyperlinks allowed you to jump from one page to another with a simple click,
Right.
creating a truly interconnected network of information.
So it's like going from a black and white silent film
Exactly.
to a full-color surround sound blockbuster.
A perfect analogy. And the development of user-friendly web browsers like Mosaic and later Netscape Navigator.
Netscape.
Yeah.
That was my first real web browser. I used to spend hours like exploring websites, learning new things, connecting with people all over the world.
It was a whole new world.
Yeah.
Those early days of the web were a bit like the Wild West.
In what way?
There was so much experimentation and innovation happening with new websites popping up every day. It was a truly exciting time to be online.
But hold on, weren't those also the days of dial-up modems? The ones that made those awful screeching sounds when you connected?
Ah, yes, the infamous dial-up modems.
I vaguely remember my parents yelling at me to get off the internet because they needed to use the phone.
Oh, I remember that too. They were a necessary evil in the early days of the web.
Yeah.
Basically, they used your existing telephone line to connect to the internet.
Okay.
Which meant you couldn't use the phone and be online at the same time.
Right. And the speed.
Oh, the speed.
It must have been like painfully slow.
It was definitely a different era.
Yeah.
Downloading a single song could take hours. But even with those limitations, the web's growth was phenomenal.
Really?
It went from a few thousand websites in the early 1990s to millions just a few years later.
That's incredible. So millions of people were connecting to the internet, sharing information, creating websites.
Yeah.
It sounds like the makings of a global phenomenon.
It certainly was.
But this explosive growth,
Yeah.
it must have also brought new challenges.
Of course.
For example, the original IP address system, IPv4,
IPv4.
was starting to run out of addresses.
That's right.
Okay, I'm going to need a little help understanding that one.
Sure.
What exactly is an IP address?
Okay, so think of an IP address like a phone number for a computer.
Gotcha.
Every device connected to the internet needs a unique IP address to communicate with other devices.
Right.
The original system, IPv4, used 32-bit addresses,
Right.
which limited the number of possible addresses to about 4.3 billion.
4.3 billion sounds like a lot.
It does, but...
Surely there weren't that many computers in the world back then.
Well, remember, we're not just talking about computers.
Right.
Every device that connects to the internet needs an IP address.
Okay.
Smartphones, tablets, smart TVs.
Oh, what?
Even some appliances these days.
Yeah, that's true.
With the internet's rapid growth, it became clear that we were on track to run out of these unique identifiers.
So what did they do? Did they just like invent more numbers?
Essentially, yes. They developed a new system called IPv6.
IPv6.
Which uses 128-bit addresses.
Okay.
This gives us a practically limitless number of addresses.
Wow.
Enough for every device on the planet and then some.
That's some serious future-proofing. Okay, so we have millions of people connecting to the web, a new system to handle all those IP addresses. The internet is booming.
It was booming.
But with this incredible growth, who's in charge of it all? Is there like some kind of internet government making all the decisions?
That's where things get a little complicated.
Oh.
The internet doesn't have a single governing body. It's more about collaboration and consensus among various organizations.
So it's like a global community.
Yes.
Working together to keep the internet running smoothly.
Exactly. Organizations like IANA, ICANN, and the IETF play key roles in maintaining and evolving the internet.
Okay, break that down for me.
Sure.
What do those organizations actually do?
Okay, so IANA stands for the Internet Assigned Numbers Authority.
Right.
And they're responsible for allocating those technical identifiers we talked about.
Okay.
Like IP addresses.
So like the internet's address bookkeeper.
Exactly. Then you have IAN.
ICANN,
The Internet Corporation for Assigned Names and Numbers.
Okay.
They manage the domain name system, or DNS for short.
Okay.
DNS ensures that domain names, like google.com, are unique and accessible.
So it's like the phone book for the internet.
Exactly. And then there's the IETF.
IETF.
The Internet Engineering Task Force.
Oh,
It's a large, open, international community of network designers, operators, vendors, and researchers.
Wow, that's a mouthful.
Yeah.
What do they do?
They're concerned with the evolution of internet architecture and the smooth operation of the internet.
I see.
It's a collaborative effort with experts from all over the world working together to develop and maintain the technical standards that keep the internet running smoothly.
Wow, that's a lot of acronyms. But it sounds like a pretty impressive system.
It is.
So many people working together to keep this incredibly complex network running.
Right.
But it hasn't always been smooth sailing, right?
Not always.
I mean, the internet has become this global platform for communication, commerce, you name it.
Yeah,
There are bound to be disagreements and controversies.
you're absolutely right.
As the internet's influence grew,
Yeah,
it became more politicized,
of course.
with debates erupting over issues like net neutrality, online piracy, and the spread of misinformation.
It's true.
Okay, let's dive into those one by one. First up, net neutrality.
Yeah,
That's the idea that all internet traffic should be treated equally, right?
exactly.
No fast lanes for certain companies or content.
Right. Proponents of net neutrality argue that it's essential to preserve the internet's open and democratic nature.
Yeah.
They believe that internet service providers should treat all data equally,
Yep.
regardless of its source, destination, or content.
So no preferential treatment for big companies or certain types of content.
Right.
Makes sense.
On the other hand, opponents of net neutrality argue that it stifles innovation and investment in broadband infrastructure.
Oh, interesting.
They believe that internet service providers should have the freedom to manage their networks as they see fit,
Okay.
which could include offering different tiers of service or prioritizing certain types of traffic.
So it's a complex debate with strong opinions on both sides.
It is a complex issue.
Yeah.
And it's an ongoing debate with no easy answers.
Okay, next up, online piracy. That seems pretty straightforward, illegal downloading of copyrighted material, right?
Yes. Although the nuances can be debated.
Okay.
The rise of peer-to-peer file-sharing networks like Napster
Napster.
back in the late 1990s
Yeah.
made it easier than ever to share music, movies, and software online.
Right.
This sparked a huge debate about copyright infringement,
Yeah.
intellectual property rights,
Yeah.
and the future of the entertainment industry.
I remember Napster.
Me too.
It felt revolutionary at the time,
It did.
but I can see how it would also create a lot of legal and ethical challenges.
It was a disruptive technology that forced the entertainment industry to rethink its business models
Yeah.
and adapt to the changing digital landscape.
And finally, there's the issue of the spread of misinformation, which feels especially relevant today.
It does, doesn't it? The internet has become a breeding ground for fake news, propaganda, and conspiracy theories.
Yeah.
This has led to concerns about the erosion of trust in traditional institutions
Right.
and the potential for online manipulation to influence elections and public opinion.
It's a bit of a double-edged sword, isn't it?
It is.
The internet has empowered individuals to connect and share information like never before.
Yeah.
But it has also made it easier to spread false and harmful content.
That's the paradox of the internet age.
Yeah.
We have access to more information than ever before.
Right.
But it's also more important than ever to be critical thinkers and discerning consumers of information.
It's a reminder that we all have a responsibility
Yes.
to be careful about what we share and to be skeptical of what we read online.
Exactly. We need to develop those critical thinking skills
Yeah.
to navigate the complexities of the digital world.
Well said. But let's not forget about the, positive impacts of the internet.
Of course not.
I mean, think about the mobile revolution. Smartphones and tablets,
Right.
they've put the power of the internet in our pockets,
They have.
changing how we communicate, work, and live.
It's true.
It's hard to imagine life without them.
It is.
The mobile revolution has been absolutely transformative.
Absolute.
The explosion of mobile phone data traffic is, mind-boggling.
Yeah.
And it all started with a simple text message. Merry Christmas. Sent back in 1992.
That's right.
Wait, Merry Christmas was the first text message ever sent.
It was.
That's pretty cool. I had no idea.
From those humble beginnings to the world of apps, social media, and streaming video we have today,
Yeah.
the mobile revolution has made the internet a truly ubiquitous force in our lives.
And the innovation continues. We're now exploring the possibilities of networking in outer space.
You're referring to NASA's work on delay-tolerant networking,
Delay-tolerant
or
networking.
DTN.
DTN.
It's a fascinating area of research,
Yeah.
focused on developing ways to handle the unique challenges of communicating across vast distances in space.
Space internet. That sounds like something straight out of science fiction.
It does, doesn't it?
What are the challenges of networking in space?
Well, in space, you're dealing with vast distances,
Okay.
signal delays,
Yeah.
and the potential for disruptions from solar flares and other cosmic events.
Right.
Traditional internet protocols, which rely on constant connectivity, just don't work well in those conditions.
So DTN is designed to handle those interruptions and delays.
Exactly. It's all about finding ways to transmit data reliably, even when connections are intermittent
I see.
or unreliable.
So, like, imagine sending a message to a rover on Mars.
Right.
Might have to wait hours or even days for a response.
Exactly.
So someday we might be browsing the internet from Mars.
It's certainly a possibility.
Wow.
And it highlights just how far the internet has come from those early experimental networks to a global communication system
Yeah.
that's pushing the boundaries of what's possible.
It's incredible to think about all the different threads that have come together to create this thing we call the internet.
I know, right?
From military research to academic collaboration, from commercial innovation to individual creativity.
It's really amazing.
It's truly a remarkable story.
It is.
But I can't help but wonder,
Yeah.
where do we go from here?
Yeah.
What does the future hold for the internet?
That's a great question, and one that we'll explore in our final part.
So we've gone from clunky telegraphs to a network that might someday reach Mars.
It's quite a journey.
It really is. It's amazing to think how far we've come. But you know what's got me really curious?
What's that?
What's NXT for the internet?
That's the million-dollar question, isn't it? The internet is constantly evolving, and it's really hard to predict exactly what the future holds.
Okay, so hit me with your best predictions then.
All right.
What kind of internet are we going to be using in like 10, 20, even 50 years from now?
Well, one major trend we're seeing is the increasing importance of decentralization.
Decentralization.
Remember how we talked about the internet's open architecture
Yeah.
and how it's not controlled by any single entity?
Right.
I think that trend is likely to continue, with more emphasis on peer-to-peer networks and distributed technologies like blockchain.
Blockchain. Okay.
Yeah.
That's the technology behind cryptocurrencies like Bitcoin, right?
Exactly.
So are you saying that the internet might become more like a giant decentralized ledger, like where everyone has a copy of the information?
It's definitely a possibility. Blockchain technology has the potential to revolutionize many aspects of the internet,
Okay. Like what?
from how we store and share data to how we govern online communities.
Interesting.
Imagine a world where online identities are more secure,
Mhm.
content ownership is more transparent,
Yeah.
and online transactions are more efficient and trustworthy.
That sounds pretty amazing. But blockchain is still a relatively new technology, right?
It is.
Are there any other trends that might shape the future of the internet?
Another major trend is the rise of artificial intelligence,
AI.
AI. We're already seeing AI being used in so many aspects of our lives. From personalized recommendations on streaming services to self-driving cars.
It's everywhere.
And its influence on the internet is only going to grow.
So how will AI change the way we actually interact with the internet?
Well, imagine searching the web using natural language,
Okay.
having your online tasks automated by intelligent assistants,
Uh-huh.
or even experiencing virtual worlds that are indistinguishable from reality.
Whoa.
AI has the potential to create entirely new ways of accessing information, connecting with people, and experiencing the world around us.
That sounds both exciting and a little scary.
I know, it's a lot to take in.
Are there any downsides to all this AI integration?
Well, one concern is the potential for AI to exacerbate existing problems like misinformation and
Right.
bias.
Right, because if AI algorithms are trained on biased data,
Exactly.
they can perpetuate and even amplify those biases.
Leading to a more polarized and fragmented online world.
Yeah, that's a sobering thought.
It is.
So it sounds like the future of the internet isn't just about technological advancement,
Right.
but also about ethical considerations
Yes.
and responsible development.
Absolutely. As we continue to develop and integrate these powerful technologies,
Yeah.
we need to be mindful of their potential impact on society.
Right.
It's not just about building a faster, more efficient internet,
I see.
but also about creating an internet that is equitable, accessible, and beneficial to all.
Okay, that makes sense.
Yeah.
So what can we as individuals do to help shape the future of the internet in a positive direction?
That's a great question. I think, first and foremost, we need to be informed and engaged citizens.
Okay.
Stay up to date on the latest developments in technology,
Uh-huh.
participate in discussions about internet governance,
Yeah.
and advocate for policies that promote a more open, accessible, and equitable internet.
So it's not just about, like, using the internet,
No.
but also about understanding how it works
Yes.
and how it can be used for good
Yay.
or for bad.
Exactly. We also need to be critical thinkers and responsible users.
Okay.
Be discerning about the information you consume online.
Uh-huh.
Be mindful of your digital footprint, and be respectful in your online interactions.
Yeah, it sounds like we all have a role to play in shaping the future of the internet.
I think so.